So here is the derivation for the calorimetric measurement of entropy. There are two steps. The first one is we'll introduce two equations that deal with a change in entropy and calorimetry. The second step is that we will assess delta S from the range T is equal to 0 Kelvin, or just 0, to T final, where the final temperature is greater than the boiling temperature. So the equations that are pertinent in this derivation is ST2 is equal to ST1 plus the interval from T1 to T2 of the heat capacity at constant pressure at a certain temperature over temperature times dt. So this involves the change in S as a result of heating. The other equation that will be important is delta S at the temperature of transition, subscript here S, is equal to the delta H of transition at the temperature of transition over the temperature of transition. So this is the change in entropy as a result of phase transition. Okay, so just to make things clear, here is an axis with T. So this is the initial temperature is equal to 0. Then we have our melting temperature. So this is where the standard enthalpy of fusion at the melting temperature is relevant. So this is where the solid becomes a liquid or vice versa. So next we have our boiling temperature, where the standard enthalpy of vaporization at the boiling temperature is important. So this is where liquid becomes a gas. And then finally we have our final temperature, where the final temperature is greater than the boiling temperature or the vaporization temperature. Alright, so from the interval T initial to T final, let's evaluate the change in S. So the entropy at T final is going to be equal to the entropy gained from heating here, the entropy gained from the phase transfer here, gained because it becomes a liquid, entropy gained from heating here, entropy gained from phase transfer, and then heating. So from the first equation, we can see that the final temperature is equal to the initial temperature. So let's just evaluate this in molar entropy, where molar entropy is the entropy of air. At Ti, which is at 0, so plus 0 to Tm, where we evaluate the heat capacity at constant pressure, or the molar heat capacity at constant pressure, where the element is a solid, or the compound is a solid, and this is at T prime. Where T prime is used in order to not confuse with TF. Now we add, so this term is the change in entropy from heating here. So now we need the change in entropy from here. So this is equal to the standard enthalpy of fusion at the melting temperature over the melting temperature. So that's that. So now we need this. So another integral from the melting temperature to the boiling temperature, where the molar heat capacity at constant pressure is evaluated when the compound is a liquid at temperature T prime. Okay, so now we need the change in entropy from the vaporization of the compound at the boiling temperature. What's that? So now we need the change in entropy over this range, TB to TF. Where the molar heat capacity at constant pressure is evaluated, where the compound is a gas, T prime over T prime. So that should equal the entropy at your final temperature.